This next question is question number 3 under the velocity section. And the question reads, calculate the distance in meters a cyclist would travel in 5.00 hours at an average velocity of 12.0 kilometers per hour to the southwest. So we'll start off like we always do with the unknown, and this one says calculate the distance. So we'll circle that, and we know that distance is d, and it says they want the answer in meters. And that's going to be important when we come back to the end, because we see down here we have a unit in kilometers, so we know we're going to have to make some type of conversion. So now what are our known values? I see 5.00 hours here, that's a time, and then an average velocity of 12.0 kilometers per hour, and we'll continue our underline because it's to the southwest. So our time equals 5.00 hours, and our velocity equals 12.0 kilometers per hour to the southwest. The equation, I'm going to start off writing the original equation that we know. We understand that our equation for velocity is distance over time. Now sometimes we have to rearrange the formula in order to get it the way we want. We need to isolate the variable. So what I did was I multiplied both sides by t so that I can get distance by itself, because then the time cancels out on this side and we're left with a new equation of distance equals time times velocity. So then when we plug in our numbers, we have d equals 5.00 hours times 12.0 kilometers per hour to the southwest. When we multiply those two together, we get distance equals 60.0 kilometers. Now we're almost done. Remember, our final answer needed to be in meters, not kilometers. So we have to make that simple conversion from kilometers to meters, and we do that by dimensional analysis. If we want the kilometers to cancel, we put that on the bottom and we put the meters on top. And how many kilometers are in 1 meter? Or how many meters are in 1 kilometer? There are 1,000 meters in 1 kilometer. So you're going to do 60 times 1,000. And that's going to give you d equals 60, and we're multiplying it by 1,000, so we can move this 3 places. 1, 2, 3. So we get 60,000. That seems like a big number, so we may want to put that in scientific notation, and we get distance equals 1, 2, 3, 4, 6.0 times 10 to the 4th meters. That's a tough one, but if you could get through this one, you can get through any of them.